we will say our one sentence prayer like we do to start class. So in the name of the Father and of the Son and of the Holy Spirit, amen. Jesus bless and center us this day, amen. In the name of the Father and of the Son and of the Holy Spirit, amen. So yesterday we did a lot of discussion between these two different types of models, right? And does anyone remember what we called each of these different fraction models? There were two names for them that we gave them, that we typed on the screen. Do you remember? Go ahead, Esther. And then Isabella, you give me the other one.
Fraction.
Okay. And which one is that? The blue one or the green one?
The green one.
Yeah, the green one is fraction of a fraction. And I know that because it's taking a part of a part, isn't it? It's not a whole yet. It's only a part of a part. And so the part of a part is double shaded, maybe with lines and shading or two different colors, but it's double shaded. That's fraction of a fraction. Isabella, do you remember the name of the other one?
Yes. The blue one is whole number grouping.
You got it, whole number groupings. And that means that you have the same fraction. Ooh, come on back there, guy. You have the same fraction copied however many whole numbers that you have. So if you had 4, like in this example, you would have 4 copies of the same fraction, 2/3. If you had 5, then you would make 5 copies of that same fraction team. And then on your homework, you had a couple that were whole number groupings and a couple that were fractions of fractions. So what I'm going to do is look at yesterday's homework and use that as my sort of platform for building on today's content. So we'll review the answers of the modeling, but then I will show you and demonstrate how to do it quickly procedurally as well, which is today's lesson. So I'm going to need you to turn to your homework page, which was 126. And Wafiq, you might not have this, but grab a sheet of loose leaf and then we can just write out the models and the answers for each, okay? So this is workbook 126 if you want to give it a title at the top of your page. So writing these first 3, they give you the model and you have to write the expression. And then the last 3, they gave you the expression and you have to make the model. But either way, we need to be comfortable knowing what kind of model are we drawing? Are we drawing whole number groupings or are we drawing fraction of fraction? Because they're different in the way that they're organized. So if you had to say number 1 was fraction of a fraction or whole number groupings, what would you say? Do you know? Which one is it? Fraction of fraction or whole number groupings? You guys feel free to unmute. It's just us.
Fraction of a fraction.
Yeah, it's fraction of a fraction. And how about number 2?
Fraction.
Fraction. And number 3?
Whole number
Whole
grouping.
number groupings. You got it. How about number 4?
Whole number grouping.
Whole number groupings. Why? Because look, there's a whole number right there, right? That means make 4 copies of 7/8. So you draw 7/8 once, then twice, then 3 times, then 4 times. You draw the same thing 4 times. What about number 5? Whole number groupings or fraction of
Whole
fraction?
number grouping.
Whole number grouping again, because you have a whole number here. Very good. And what about number 6?
Fraction of fraction.
Fraction of fraction. So you're getting really good at, before you even start the problem, you know what to expect. It's going to look like this. It's going to behave like that. And that's good to know when you're approaching a new type of problem. Okay. So let's go after. Did someone have a question?
I have a question.
Okay.
I already did this page yesterday for homework.
I know. We're checking it together and I'm going to push today's instruction alongside it so that we can connect the two.
Okay.
All right. So when you did this problem, you first had to look at this model going up and down, right? And when you look at it going up and down, you can see 1 out of the 4 strips have these lines on them, right? So 1 out of 4 means the fraction 1/4. It doesn't matter if your 1/4 is here or here, right? Because you might have looked at this side first. You might have looked at the strips going side to side first. And what fraction would you have seen if you looked at the strips that are shaded going side to side? What fraction is that? So look at side to side. How many are blue shaded? 2 out of 3.
3.
So we would say 2/3 are shaded blue. This is where I think your math book should have used 2 different colors, guys, because if I were teaching this at school, and we could actually engage with each other a little bit more, I would say, okay, this represents the yellow fraction, and this represents the blue fraction, and their overlap is the green part. Do you see the overlap where it's green? Do you see that? How many pieces are green?
3.
Well, I see this one has blue and green, blue and yellow. This one has blue and yellow. This one has just the yellow, just the stripes. Do you see how these two have both? That's the overlap, right? That's the fraction of a fraction. That's the spot where they both connect with each other. So there's 2 spots colored, right? With both. But what's the value of one of those spots called? It's not 1, because that whole shape is worth 1. So what is one piece of that 1? What's the value of one of those pieces? Well, you would have to look at the whole group and say, well, if there's 12 altogether, then one of those pieces is worth 1/12. Does that make sense? Why one of those pieces is worth 1/12? How about this piece? What's the value of that piece? 1/12, right? So how many 12ths represent the answer? 2 of them, right? So 2/12 represents the answer, the part that's green, the part that they both overlap on. So 2/12 is the solution for this multiplication expression. 1/4 times 2/3 is equal to 2/12. Look at how easy this is. This is today's connection. Ready? What's 1 times 2? 2. What's 4 times 3?
12.
12. Isn't that easy? So the model brings it to life a little bit. It puts it on paper so we can visually see what's happening when you multiply 1/4 times 2/3. But the procedure is super easy, isn't it? You just zip straight across the numerators, zip straight across the denominators. You don't need common denominators. That's it. So the most kind of challenging part is probably reducing the fraction, but that's a skill we're building confidence on. We look at 2 and 12 and we say, do they have anything in common with each other? So 2 and 12, I know they do. They're both even, so they at least have a 2 in common with each other, right? So if I divide off a 2 off the numerator and divide off a 2 off the denominator, what would the reduced form of this fraction be?
1/6.
1/6. So we're going to work more on simplifying, reducing today as well. But I'm using yesterday's homework to give instruction on today's topic, which is the procedure just goes straight across. Okie dokie. So before I even look at this model, this is something that I think you guys are a little bit fuzzy on. Before I even look at this model, I'm going to shade it with a different color on top, just so this part looks different than the other part a little bit for you. Okay. So now you can clearly see the difference. There's a yellow part and a pink part. What fraction is being shown with the yellow part. So this part here, in regards to the whole, how many pieces is it broken into? So the whole group is broken into 2 pieces, right? And one of the 2 pieces is shaded yellow. So 1/2 is the yellow part of the fraction. And what about the pink part of the fraction? So going the other direction, we have 2 out of the 3 sections shaded, right? So this is the fraction 2/3. Was everyone able to see that?
Yes.
It's like layering a fraction model on top of another fraction model. So you have to think of these models as clear, as like translucent, so you can see through them to what the overlap between them would be. You know, in the classroom where you have those page pockets where your teacher might put something inside of them and then you write something with a dry erase marker on it and then you can wipe it clean. Well, when I teach this topic, normally what I do is I bring those and I have one person draw the 1/2 and I have one person draw the 2/3, and then they stack them on top of each other. And so you can see through both of the page protectors what the overlap is, and then they can see the answer here. So do you see where the overlap is? These 2 pieces right here? What's the value of one of those pieces? So you have to think about the whole group, right? So one of how many are in the total group?
6.
So 1/6 is here. Here's another 6th, right? So the answer is going to be 2/6, right? Let's check the procedure and see if that worked out as well. 1 times 2, 2, done. 2 times 3, 6, it worked, right? So super easy. Let's reduce that fraction down to lowest terms. 1/3. Which means the same thing as 2/6. So 2 out of every 6 are shaded twice. 1 out of every 3 are shaded twice. So it's the same equivalency. It didn't change the model in any way. It just changed maybe the way that you're looking at it. It's still 1 out of every 3 are shaded twice. Okay. What do you think this procedure will work for whole number groupings? The procedure, the straight across method? Let's find out. So for whole group modeling, you say, well, here's one fraction, right? And this fraction is called 2/3, right? This fraction is called 2/3. How many copies of 2/3 did I make? 1, 2, 3, 4, 5 copies of 2/3. So the expression that you should have written on the line is 2/3 times 5, or 5 times 2/3, 5 groups of 2/3, 2/3 times 5 copies. It doesn't matter. Multiplication starts with the C. I can reorder it and it doesn't change the value.
Composite.
Starts with the C. What properties? Multiplication is
Commutative.
commutative. Good job. So the ordering of that expression doesn't matter. 2/3 times 5 is the same as 5 times 2/3, right? So still, I do need to know what's the value of one of these pieces though. So if this is one whole and I'm pointing to one of those pieces, what's the value of one of those pieces? 1 what?
1/2.
Well, how many are in the whole?
3.
1/5.
3, right? So that's one of the 3 pieces, isn't it? Is that one of the 3 pieces that I'm pointing to? Okay, so if that's 1/3, how many thirds are shaded? 1, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3. 10/3. So did the procedure work? Let's see. Well, 2 times, wait a minute. 5 is just a big old number. How can I make 5 look like a fraction? Does anyone remember how to change a whole number into looking like a fraction? Michael, what do I do?
I think first you're supposed to do 5 over 5, but that doesn't work, so you make it a 1.
It's a
You break
1.
1
right.
up.
It's a 1. 5 over 5 would be equal to 1, but then that would change the value of the 5. We want the 5, the numerator, to have more magnitude, right? So we can use the denominator 1 doesn't change the value of 5 at all. 5 divided by 1 is still 5, right? So anytime that we need a whole number to look like a fraction, all we do is push it up into the numerator, and what denominator do we use? 1. And does the procedure work now? 2 times 5, is that 10? 3 times 1, is that 3? But you should be going, wee-oo, wee-oo, wee-oo. What's going on here?
Improper fraction.
Improper fraction alert, right? So here we go. We're going to have to do something about this. 10 divided by 3, you can do that off to the side. You might be able to start doing that part in your head. It would be 3 whole times, right? With 1/3 left over. So that would be the final simplest form of this answer. So even with whole number groupings, the procedure straight across works if you convert that whole number into a fraction. So you can still use this quick and easy procedure. Someone in the other class, I wanted to show you this. They said, well, I can see that happening in the model. They moved in their mind, they took this purple piece and added it to this grouping right here. So they filled it up. And so now this one's gone. And then they took this one and filled this guy up. So now this whole thing is gone over here. And then they took this one and filled this guy up. Just moved it like a slice of pizza. So this one's gone. So what do you see as leftover now? You see one whole group filled up, right? 1. Another whole group filled up, that's 2. Another whole group filled up, that's 3. And then how many leftovers? 1/3. Doesn't that match this mixed number? 3 whole groups and 1/3 left over. You see the connection to the model? It's a little hard to do on a screen. If you had like cut up pieces of paper in front of you, it would be easier to comprehend. But this does kind of do the trick a little bit. Okay, so the last 3, now you're given an expression, and we're going to do it 2 ways. We're going to do the model for it to show that you understand the modeling technique, and then we're going to do the procedure just to make sure that we understand today's content. You just go straight across, right? So 7/8 times 4, you told me that this is like saying I have one fraction called 7/8. So let's see if I can make a 7/8 real quick. But then I have 4 copies of it. So on my computer, this is going to take a little bit of time. But if this is 7/8, right? If this is 7/8, and I have 4 of them, how many pieces will be colored all together? And what's the value of one of those pieces? So I'm going to keep drawing while you're working. I hope you did this model for yourself yesterday. So I have 4 copies of 7/8. I'm trying my best to make them equal. Don't mind me here. So 4 copies, and they each have to be 7/8 of the way full. This kind of reminds me of the cereal box phenomenon at my house. It doesn't, I don't understand how somehow there's always like 1/4 of the box left at the bottom of the bag, and yet people get a new box out. So I'm going to just color 7/8 for each of these. So do I have 4 copies of 7/8 now? Something pretty close to it. Do I have 4 copies of it? I have 4 copies of 7/8. And I need to identify for myself, well, what's the value of one of these pieces? So one of these pieces is an 1/8, right? Because it's out of 8 parts. So how many pieces are shaded altogether? How many 1/8ths are shaded altogether? So there's 7 here. There's 7 more, that's 14. There's 7 more, that's 21. There's 7 more, that's 28 altogether, right? So 28 1/8ths are shaded altogether. 28 1/8ths. And we say improper fraction alert, and we can convert that into a mixed number. But did the procedure work if you used 7/8 times, here, I'm going to sneak it over 1. 7 times 4, 28. 8 times 1 is 8. So it did work. The procedure worked. Improper fraction would be, what do we get when we convert it to improper fraction? 3 and 4/8. Can 3 and 4/8 be reduced at all? Simplified? By what? What can be reduced? What can be taken out of them? A factor of 2, right? So if I take out a factor of 2, that would still just get me 2/4. Can it be reduced some more?
1/2.
Yep, I can reduce it down by another factor of 2. So could I have started at 4/8 and reduced it by a factor of 4 right away and gotten to 1/2? Yeah, you can do that. You don't have to do one factor at a time. You could do 2 times 2, 2 times 2. If they both share 2 2's, then you can remove them both at the same time. I'm going to skip over to number 6 here. Quickly, what would the procedural answer for this one be? What's 5 times 1?
5.
5. And 6 times 2?
12.
12. So we know the answer is already going to be 5/12. But how do we demonstrate it with a model? So a fraction of a fraction is going to have to be in one whole box, showing one fraction modeled this way and the other fraction modeled this way, and their overlapping piece is going to represent 5/12. Okay? So when I'm getting ready to draw a fraction of a fraction, I need to have a whole number group representing one whole. And then I'm going to demonstrate this fraction maybe going up and down, and this one going side to side. So 5, 6 going up and down, I need 6 even sections, as even as can be. 1, 2, 3, 4, 5, 6. Not bad, not bad. And I'm going to shade them yellow. I'll shade them yellow. 1, 2, 3, 4, 5 out of 6, and that's going to be the yellow fraction is being shown here. I'm going to go the other way and show 1/2. So to show 1/2, I need to cut this whole section into 2 parts, right? 2 parts. So straight across the middle, and one of those parts has to be shaded. So I'm going to see if I can use blue here, if it will layer on top of it. Oh, good. And it does show a little bit greenish. Do you see how the overlap is greenish? That's good because that shows the answer, right? What's the value of one of these little pieces worth? Well, there's how many altogether, guys?
There's 12.
There's 12 altogether, so one of them is 1/12. How many are double shaded? 1, 2, 3, 4, 5/12. Hey, that's the answer I got, right? That's the procedure answer I got. So on a coming quiz, I would have you demonstrate both the modeling approach and the procedural approach to prove that they both match, okay? We're going to continue to work on this skill because I think it will help your overall comprehensions, like your left side of your brain and your right side of your brain working together. the visual sense, the calculation sense of it coming together and combining. So for today's assignment, I'm going to pull up that page real quick. For today's assignment, you'll notice that we're going to look at a couple on 127 here before you go. On 127. Can't believe we're already in chapter 8. This is crazy how quick the school year is going. I think it's just so busy, and every week is a new set of challenges that it's really been making this year fly. But I'm really excited that I have you again for math next year, because I can build on some of your same vocabulary terms, methods that I teach. I think this will be really exciting for us as math students as the years go. Okay, I think I got it pulled up here. I'm on 127. We're not going to do all of these, but look at how quick the procedure goes when you go straight across. So 2 times 1, 2, 3 times 4,
12.
and then the only thing you have left to do is simplify it into lowest terms if possible. So do 2 and 12 share any common factors with each other? They share 2, right? So if I divide away a 2 from both the 2 and the 12, what am I left with?
1
1,
over
6. And we know that if we have a 1 in the numerator, 1 and done, right? So this one is all done. Number 2, 1 times 3, 3. 2 times 4, 8. Do they share any common factors besides 1, 3,
No.
and 8 is 2, 2, 2. So no. So no factors other than 1. I'm done. How about this one? 5 times 1, 6 times 6.
36.
Do they share any factors?
No.
Nope, I'm done. Next one, 2 times 3,
21. I mean, 6.
5 times 7.
35.
Mhm. Okay, so I'm done. They don't share any common factors either. How about you do 5, 6, 7, 8 for me? And I'll be quiet here for a second. Don't forget to simplify. if
I have a
possible.
question from I have a question from yesterday's homework.
Okay.
Since I didn't have my book and I didn't turn the thing, I wasn't able to do it, but I already checked it. So should I still turn it in?
So did you draw what I drew?
Yeah.
Take a picture of that. Okay, that's what you can turn in. I'm fine with that. I want to see that you participated with the content. And if you wrote it down while we were discussing it, that's fine. Okay?
Got it.
Yes. Esther, question, or you have an answer for me?
Oh, I'm done.
Okay, number 5, what'd you get, honey?
I got 1 over 12.
Good. Who else? Thumbs up. Who else got 1/12 for that one? Oh, yeah. All right, number 6. Go ahead, kids. So at first I got 12/20ths, but Michael, can this one be simplified at all further?
Yes, and we simplify
Yes.
twice, and it goes into 3/5 to end it.
Okay, so 3/5 is the lowest form of it, right?
Yes.
Okay, so some people had trouble with that one in the classroom, and so I suggested to them to use something they already are comfortable with, and that's factor trees. So if you had a hard time reducing that or simplifying it, you've already practiced using factor trees, right? So use them to your advantage. Here's how factor trees work when you're trying to put something in lowest terms. This is taking forever to write with the mouse. Sometimes when I Zoom you guys, I have this little drawing tablet that I can plug into my computer, but that's only on my laptop. And we heard the internet's kind of shady here at school today. So I wanted to use a real computer and not rely on the wireless. So it has its gives and takes, I guess. So what do you notice they have in common? What's their greatest common factor? They both have 2 2s, right? So pretend I'm covering them up and they're gone. What's left over? A 3. And what's left over in this factor? A 5. So when you remove the greatest common factor, is what you're doing when you divide away a 2, then divide away a 2. You're removing them. You can see what leftovers come out. You have a 3 left over and a 5 left over. Who connects with that idea that each number is a collection of its prime number Lego parts? Do you remember when we did that? We talked about how a number is really like a shape that contains different Lego pieces. So a 12 would have a 2, and a 3 piece, and a 20 would have a 2, and a 5 piece. So if you took those two pieces out of the equation, then you have a 3 and a 5 piece left. So that's a more conceptual way to think about it. So for number 7, 3/12 can be simplified by pulling out the 3, and you're left with 1/4. Number 8, you get 10/18, but can pull out that factor of 2, and you're left with 5/9. How'd you do with that one? So down here on the bottom, I'm going to skip here to the bottom real quick. We're going to be comparing the value of fractions against fractions. So remember that the bigger a denominator gets, it's actually a smaller fraction, right? So for instance, which fraction is bigger, has more value, 1/3 or 1/5? Which one has more value? So imagine what a visual model of 1/3 would look like, and then compare it to what a model of 1/5 would look like. Which one would have bigger sections? Which one would have smaller sections?
1/3.
1/3 would have bigger sections, right? Because the whole is only broken into 3 parts. The fifths would have smaller sections because you have to fit 5 slices in one whole. So really, when you multiply them together, would 1/15 or 1/12 be bigger in value? 1/15 or 1/12? Which one would be bigger in value? Wafiq, which one?
1/12.
1/12 would have a bigger value than 1/15, right?
Yes.
That means I need to make this inequality symbol face the open mouth towards the bigger value. Remember, because the hungry alligator, what does he do?
Do
Eat
not remind me. of that.
Value that is greater,
I
right?
don't like that song. It got stuck in
I'm
my
sorry, I had to do it with Wafiq. I'm sorry. The hungry alligator eats the value that is greater. So he wants to eat the greater one, right? So we have to put his open mouth towards the greater one. This is just a little sneak peek at how to manage these. All right, what about 2/6? That's this side. 2/6 compared to 4/12. Ooh, 4/12. That needs to be, they both need to be reduced, don't they? So 2/6 would be 1/3. And wait a minute, 4/12 is 1/3, isn't it? So what symbol do I put between these two guys? Beep. Equals, right? They're exactly equal in value to each other. I'm going to clear my drawings here and scooch onto your homework. You are only doing 1 through 12. 1 through 12. You do not have to draw a model, but you're welcome to if you're feeling like you want some more practice with that skill. Now, these are all fractions of fractions. Tomorrow is fractions of times a whole number. So we'll practice that a little bit more tomorrow. But fractions of fractions is here. I'm going to tell you that for number 12, you're only doing 1 through 12. For number 12, it says that she's going to use 3/4 of each of these, okay? So when it says of, what word are they meaning? Of is what type of a word? A multiplication word, right? So if she's using 3/4 of the red paint and 3/4 of the blue paint, then you need to make two expressions that show that's what's happening. And it looks like, how much paint does she use in all? It looks like you're going to end up combining those values at the end. So we're going to take 3/4, wow, of 3/4 for the red paint, find an answer. And then we're going to take 3/4 of the blue, find an answer. And then you're going to combine them. How do you combine them? With addition, right? What do you need to add fractions? Common denominators, right? So it's not going away. We're going to keep revisiting common denominators. You're going to get a little taste of it here on number 12 is the common denominator thing. Now, I wanted to let you know also that your quiz from chapter 6-7 is on Google Classroom. It's graded. So if you go back into your original test, you will see that there are markings on it. And the markings will tell you which ones I want you to fix or which ones I want you to do again. So even each problem was about 2 points. Even if you only got a half a point off, I want you to redo the problem that you were marked incorrect on. Correct it even if your bonus point picked your score up enough to give you a perfect score on your test overall. Still fix the one or ones that you had some points taken off on, okay? Wafik, I have your test. Michael, I have your test. What I'm going to do is take a picture of it and email it to you so that you can make your corrections. Did you notice that I also put together a corrections video to help you through your work? Okay. So if you needed some more support with any of the questions that were on your test, I would go watch that test corrections video to help support you in fixing your answers. So the test corrections assignment's not due until Friday. So you have a little bit of time for that. I would do today's homework first. And then if you have some time later tonight or tomorrow, you can work through that. We're not going to have math class on Friday because we have a half day here at school, and I see 6th graders that day. So we won't have math class on Friday. If you would like to maybe reserve some time on Friday for doing your test corrections, you'll have the time built in. All right, any questions?
Do the bonus points